SpaceX just attempted something that would have been impossible 5 years ago. They launched Starship Flight 7, and for the first time, they achieved something that changes everything about reusable rockets. Welcome back, and today we're breaking down Starship Flight 7, the test that proved the dream is actually working. Okay, so let's set the stage. Starship is SpaceX's next-generation super heavy lift vehicle. Two massive components stacked together, the Super Heavy Booster 33 Raptor engines and the Starship upper stage. The goal: make rockets fully reusable. Land the booster, refuel it, launch it again within hours. That's the game changer. Now, flights 1 to 6 were all about learning. Explosions, failures, partial successes, all testing new systems. Pushing limits, collecting data. But Flight 7? This was the inflection point. For the first time, SpaceX wasn't just testing individual systems. They were testing the whole operation: launch, stage separation, booster catch, upper stage mission, re-entry, recovery. Everything. And they pulled it off. This wasn't just another test flight. This was proof that the future of spaceflight is becoming real. Let's rewind and understand why Flight 7 is such a big deal. Flight 1, April 2023, the odd test. Starship went boom. Literally lost structural integrity 30 seconds after launch. But SpaceX learned tons. Every failure is data. Flight to November 2023 made it further. Got through max Q. Booster crashed. Upper stage crashed. But they were pushing the boundaries. Flight 3, March 2024, even better. Booster attempted a catch, didn't work, but they tried. That takes guts. Upper stage splashed down more or less intact. Flight 4, June 2024, this is when things got interesting. Booster catch worked. The chopstick arms at the launch tower actually caught a falling 33-engine rocket. It was unhinged. Upper stage did controlled re-entry and survived splashdown. Flight 5 to 6, incremental improvements. Better catch precision. Longer upper stage burn. More orbital operations tested, more data collected. By Flight 7, SpaceX had learned enough that they could execute a full mission, and that changes everything. Flight 7 had some ambitious objectives, primary goals: booster catch again, successfully catch. The Super Heavy Booster using the launch tower arms. Repeatability is key. If you can't catch it consistently, it's not reusable. Stage separation at altitude. Separate booster from upper stage at very high altitude and speed. The higher and faster, the harder the separation. Extended upper stage mission to keep Starship in space longer. Test orbital procedures. Demonstrate longer duration flight, collect data on vehicle behavior in the vacuum. Re-entry telemetry, survive re-entry from near orbital velocity and transmit real-time data. How do the heat tiles hold up? What's the thermal environment like? This data is critical. Controlled descent to actually guide the vehicle to a specific splashdown zone, not just somewhere in the ocean. Precision matters for future landing operations. Propellant transfer simulation, test the systems and software needed for orbital refueling. This is how you do long-duration missions and Mars missions. Any three of those would be a good day. All of them? That's a historic flight. T-minus 10 seconds. The countdown. You can feel the energy at the launch site. T-0. All 33 Raptor engines ignite. Starship clears the launch tower. Acceleration is smooth. The vehicle is climbing. First stage is performing nominally. We're in the subsonic regime, accelerating through the sound barrier. Seconds ticking. The vehicle is at full throttle. Max dynamic pressure incoming. This is where structural stress peaks. T plus 60 seconds. We're through max Q. Booster handled it perfectly. Vehicle is supersonic, still climbing. T plus 2 minutes 30 seconds. Stage separation time. This is the moment. The booster's main engines throttle down. The stage separation mechanism fires. And for the first time in flight history, this separation happens cleanly at high altitude and high speed. Booster separates from upper stage. Upper stage's second stage engines ignite. Booster flips around and initiates its boost back burn. This is a controlled deceleration that guides the booster back toward the launch site. Upper stage continues climbing, heading toward orbital velocity. Starship is now ascending to space. The engines are firing perfectly. The vehicle is stable. We're approaching space. Meanwhile, back at the launch site, the booster is descending. The mechanical arms, the chopsticks, are positioned. The booster comes down at thousands of feet per second. The arms reach up. And a catch. The arms grab the booster perfectly. It's not a crash landing, it's a catch. The booster is being held suspended by the tower arms. Mission control erupts. This is the second successful booster catch. Repeatability achieved. Proof that this can be a normal operation. Back in space, Starship is coasting. The upper stage is now in a suborbital trajectory heading toward orbit. Solar panels are deployed, if equipped. Systems are being tested. The vehicle is going to space. Time passes. Starship coasts higher, approaching the edge of space. Then Starship initiates its re-entry. This is where things get real. The vehicle screams back into the atmosphere at Mach 25. The heating is intense. The outside reaches thousands of degrees. Heat tiles are glowing. The structure is screaming under aerodynamic forces. But the vehicle holds. The guidance system is maintaining attitude. The software is doing its job. The thermal protection is working. Altitude dropping. Speed decreasing. The plasma layer is thinning. Starship is slowing down. Lower and lower. Descending through the atmosphere. And his splashdown. Starship hits the Indian Ocean. Not an explosion. An actual, controlled splashdown. And it's relatively intact. Recovery teams immediately move in. They're looking at the damage. Heat tile condition. Structural integrity. What worked? What failed? What's the data telling us? Initial assessments, Starship survived re-entry better than previous flights. Some heat tile damage expected. Some structural degradation expected. But the vehicle came back as a data source, not a total loss. That's not a failure. That's a mission success. Okay, so why does Flight 7 matter? Why is this the inflection point? Because Flight 7 proved something fundamental: reusability is actually achievable. See, before Flight 7, people said maybe you can catch a booster. People questioned whether it was practical, whether the timescale made sense. Flight 7 said, no. This is normal. This is how we operate. Let me explain what this opens up. 1. Dramatic cost reduction. If you can catch a booster and reuse it within hours, instead of years or decades, your cost per flight plummets. Instead of $500 million to build a new booster, you refurbish and fly again for $5 1 OM. That's not incremental. That's transformational. 2. Launch cadence. Right now, SpaceX can only do a few launches per month. With fully reusable boosters and fast turnarounds, you could theoretically do dozens per month. That's orbital infrastructure. That's changing access to space. 3. Mars missions become economically feasible. Mars missions require massive fuel depots in orbit. You need 10 Starship launches to move one mission to Mars. With costly boosters, it's economically impossible. With reusable boosters, suddenly, Mars isn't someday. Mars is in a decade or two. Seriously. 4. Orbital refueling. Flight 7 tested the systems needed for orbital refueling. Multiple starships in space, transferring propellant to each other. That's the technology that makes deep space exploration real. 5. Commercial viability. SpaceX wants to offer launches to paying customers. But they can't if every flight costs $500 million. With reusable boosters, the economics work. Space becomes accessible. Here's the bigger picture. Flight 7 wasn't just a test. It was a statement. SpaceX said, "We figured out how to do this. The technology works. The procedures work. The operations are becoming routine." That's the inflection point. That's when impossible becomes inevitable. But let's be real. Flight 7 wasn't perfect. What went wrong or not as planned? Heat tile damage was still significant. SpaceX is working on better adhesion and more durable materials. Some avionics experienced high temperature exposure. Sensor hardening needed. Upper stage re-entry was messy. More controlled than previous flights, but still some unplanned structural breakup in the upper atmosphere. Booster catch, while successful, showed some oscillations in the arms. SpaceX is improving damping and control. But here's the important part, none of these are showstoppers. They're engineering challenges. SpaceX has already started solutions. The road ahead, Flight 8 will incorporate Flight 7 learnings, improved heat tile formula and adhesion. Updated sensor packages with better thermal protection. Better booster catch arm control. Enhanced upper stage guidance algorithms. SpaceX is targeting Flight 9 for the first full stack catch. Not just booster, both booster and upper stage caught by the arms. That sounds insane. But if you understand how close they are, it's actually achievable. After that, orbital refueling tests. Docking in space. Real payload missions. The timeline is aggressive. But Flight 7 proved they're on track. Here's what Flight 7 really represents. Every revolutionary technology starts with someone saying that's impossible. Reusable rockets. Everyone said it couldn't be done. The physics was wrong. The economics didn't work. It was a pipe dream. But SpaceX said, "Watch this." Flight 7 was watching that. It's proof that when you combine brilliant engineers, fearless risk-taking, rapid iteration, obsessive data analysis, culture that celebrates learning from failure, you can make the impossible real. Starship isn't just a rocket. It's a symbol of human innovation at scale. It's what happens when you refuse to accept impossible as an answer. And Flight 7 was the moment we knew it was actually happening. Not in some distant future. Now, while you're watching this, that's worth celebrating. So here's what I want you to take away. Flight 7 wasn't just another rocket test. It was proof that the future of spaceflight is being built right now. Reusable rockets are real. Mars missions are coming. Humanity's path to becoming a multiplanetary species is underway. And you're living in the era when it's happening. So what do you think? Are you excited about Starship? Do you think we'll actually see a fully reusable spacecraft in the next 5 years? Drop your thoughts in the comments. I read every single one. If you love space exploration, SpaceX, and engineering breakthroughs, hit that subscribe button. New deep dive videos every week. Thanks for watching. I'll see you next time.